Bonjour and good afternoon. Welcome to WASA Distance Education Center and PLAR Science. Okay, we're into week 7, and this is our 12th class for PLAR Science. We have, after this week, we have 2 more weeks left, and we're done for term 2B. Just a reminder to students that if you would like to apply for term 3, that's June 24th to August 23rd, we have some courses available. We have English, math, science, history, and co-op. So if you're looking to apply for English, there's NBE 3C, ENG 3E and 4E, 4C and 4U. For math, there's the grade 11 workplace math, MEL 3E, MBF 3C, MAP 4C, MCT 4C. For science, there's SNC 2P, SVN 3E, SBI 3C, SCH 4C, which is the grade 12 college chemistry, and the grade 12 university biology, which is SBI 4U. For history, we have available CHC 2P and the NBV 3E, and for co-op, DCE 30, DCO 30 is the co-op code. Also the OLC 40, which is a literacy course, that is also available under the English courses. If you want to apply, you can apply with your local DEC, or you can contact Michelle. You could also use our online application form. Any PLAR students or future PLAR students or PLAR students that would like to reapply, you can contact Candace for that. We will also have the term 2B draws at the end of the term. As you know, we have 2 student draws, so one for students who earns a credit and one for students who submit work. So make sure you're submitting your work to your teacher so that you can be entered into the draw. Students who are working on more than one course will have their names entered for each subject that they submit work for. Make sure you contact your teacher if you're needing any help with completing with any of your PLAR courses. You have different ways to submit your key questions. Remember, you can still email your own work to studentwork@nnec.on.ca. Make sure you CC it to your teacher. You can also use your Notes app to scan email. You can send us a picture through Messenger, or you can drop it off at our WASA office, or you could use the outdoor mailbox that's located on the side entrance. You can submit your work as you complete them. You don't need to complete all of lesson 1 or complete all the lessons, say for example PLAR Science. You can submit them as you are completing them. And again, if you're having any problems, make sure that you contact your teacher. So those students that are working on PLAR Science, PLAR Geography, and PLAR History, remember the videos will be left on YouTube for the summer if you want to work on them. We won't be marking PLAR over the summer, but if you would like to work on them, you are more welcome to, especially if you have your packages. Remember, all PLAR packages are the same whether you are registered in Radio Zoom or IL, and you can continue where you left off. And if you're not sure, make sure you contact your teacher. So students who are working ahead for PLAR Science, you can go to the PLAR Science classes that's on YouTube. For students working on PLAR Geography, you can check out the PLAR Geography 2A and the PLAR History 2A. There is one for PLAR Science for term 1B. Just don't have the picture here, but it is there. Or if you don't want, or if you don't have internet or Wi-Fi, you can still request a USB of classes. Just make sure that you check which lesson that you are needing help with. So for example, maybe you need help with key question 42. So check out PLAR Science Lesson 3 under key questions 41 to 44, and key question 42 should be in there. Classes can be viewed on your laptop, television, Xbox, or PlayStation. So we are here, week 7, lesson 4, physics. We might not need all 4 classes because lesson 4 is shorter. So we might only have this week to do physics. We will be finishing up lesson 3 today, and then we will start with lesson 4 physics. Students who still have their culminating activity, and there are students who have them, make sure that you submit. First, make sure you complete them, and then you submit them so that you can get your equivalent credit. Remember, if you do not submit your completed culminating activity, then you will not get an equivalent credit for grade 9-10 science. We have for this afternoon key question 59, 60, 61, 62, and 63 to complete, and then we will be finished with chemistry. So remember, make sure that you check out the teacher comments or marks to student. If you have submitted any work, you will receive this, and it's a good checklist to make sure which items or key question you have completed or you might need to resubmit. So this is what's left. Page 39, safety rules for using chemicals. We talked about that from our last class, so we'll do a quick review on that. Then page 40, lab safety, WHMIS or WHMIS. Page 40, also chemical hazards, and then we will look at on page 41, hazard symbols. So here are the safety rules for using chemicals. So if you're working with any of the chemicals, make sure that you read the labels of all chemical bottles before you actually handle them. Never handle chemicals with your bare hands. And never taste chemicals. You should be able to recognize hazardous product symbols. So for example, the skull and the crossbones, that means acute toxic. This one, health hazard, shows you a picture of the head and the chest, and then there's this looks like a star next to the chest part there, and then flammable shows a picture of flames. So make sure that you are able to recognize hazardous product symbols. When using chemicals, use only small quantities. Never return excess. So for example, if there are leftover, that's what excess means. Do not return it to the original container unless it says to return it to the original container. Always replace the lid on the container, as some chemicals react with air or the moisture in the air. When checking the odor or the smell of a chemical, do not smell it directly. So that means you don't put the chemical directly under your nose. The proper way to do it is you use your hand to wave or waft the vapors towards you. Clean up chemical spills immediately. So if you spill something, clean it up right away. Use plenty of water to immediately rinse any spills, whether it's on your clothing, your hands or body parts, or in your eyes. Do not pour unused chemicals down the sink. Make sure that you read the instructions, dispose of them as instructed in the activity. turn to page 40, Lab Safety or WHMIS. So the Workplace Hazardous Materials Information System, that's what WHMIS stands for, is a national system for safe management of hazardous chemicals. So according to WHMIS, it provides that workers must be informed about the hazards in the workplace, and they should receive appropriate training to enable them to work safely. And for them to do that, WHMIS requires all suppliers, so whether it's the manufacturer, the importer, packagers, and processors, they have to label and prepare what's called as safety data sheets, also referred to as SDS, for products that they make, they import, package, or process. Employers must set up worker education programs that instruct workers about the contents. That means what's in it, okay, and what's significance of the labels and the safety data sheets. So that should say SDSs, and how to work safely with that type of material. In summary, WHMIS delivers the necessary information by means of cautionary labels on the containers. They should also provide an SDS, which is the safety data sheet, for each controlled product, and they have to have a worker education program. This means that the ultimate goal is to create a safer workplace by providing workers with the knowledge, meaning they should know, and the tools to enable them to work safely. So for example, here's a label, and it shows you the product, and it's in 2 languages. It's in English and it's in French. So it says product K1, and then there's your symbols. So make sure that you know what the skull and the crossbones mean, and this one has an exclamation mark. So what does that mean? It says danger, fatal if swallowed, causes skin irritation. Okay, so if it's ingested, could be fatal, so if you swallow it, and causes skin irritations. Precautions, so what must you do when you're working with this product? Wear protective gloves, wash hands thoroughly after handling, do not eat, drink, or smoke when using this product. Store locked up, dispose of contents or containers in accordance with local regulations. And then it also tells you what happens if you get it on your skin. So if on skin, you have to wash with plenty of water. If skin irritation occurs, you should get medical advice or attention. If you get it on your clothing, you have to take off contaminated clothing and wash it before use or reuse. If swallowed, you have to immediately call a poison center or doctor, and you have to rinse your mouth. So that's an example of what might be on a product based on the legislation for WHMIS. Chemical hazards. Chemical hazards may be described under 3 broad headings: flammability, reactivity, and health. So it falls under those 3 types. So the first one we will look at is flammability. So flammable substances are those that can easily catch fire and burn in air. A flammable liquid does not itself burn, but it is the vapors from the liquid that burn. So for a liquid, the flash point or auto ignition temperature, explosive limits, vapor density, and ability to accumulate an electrostatic charge, these are important factors in determining just how much it is a fire hazard. Here's an example. There's examples of flammable and combustible liquids like isopropyl alcohol, propane, Solvents such as acetone, MEK, or paint thinner. Fuels such as gasoline, kerosene. Aerosol cans. Combustible liquids, oil, greases and lubricants, and oil-based paints. You may notice on, say, if you're getting gas at the gas station, it will say do not smoke at a certain distance, or turn off ignition, okay, when you're near the gas pumps. Here's another one. This one is for an air freshener. So you might see one in the public washroom, or maybe you even have it in your own home. It says fragrances the air, neutralizes unpleasant odors, suitable for any room in the house. It tells you the directions. So shake can well before use. Hold can upright and spray towards the center of the room. Do not spray directly onto fabrics or furniture. Suitable for any room in the house. There's your hazard symbol. It shows flammable gas. It says extremely flammable. Do not spray on a naked flame, and meaning if you have a candle lit, that means don't spray it on there, or any incandescent material. Keep away from sources of ignition, so no smoking. Keep out of reach of children. And it says propellant is hydrocarbons. Other instructions for it, it says pressurized dispenser, protect from sunlight, and do not expose to temperatures exceeding, I think it says 57 degrees. Do not pierce or burn even after use, meaning you don't try to put a hole in the can. Use only as directed. Intentional misuse by deliberately concentrating and inhaling contents can be harmful, or that. And then it says dispenser must be empty to be recycled. So some of these items you might have at home, for example, again, air freshener, something for cleaning. Lysol kills bacteria and mildew. Rust tough, so maybe it's something that you spray to prevent rust. There's spray paint. So ordinary household products that you may have around your home, make sure that you are aware of the hazard symbols on them. Next is reactivity. So reactive chemical hazards invariably involve the release of energy or heat in relatively high quantities or at a rapid rate. So if the heat evolved in a reaction is not dissipated, the reaction rate can increase until an explosion results. So if you look at the example here on the slide, look how sodium reacts with water. It actually ignites. So some chemicals decompose rapidly when heated. Light or mechanical shock can also initiate or generate explosive reactions. Some compounds are inherently unstable, and they can detonate under certain conditions of pressure and temperature, while others react violently with water or when it's exposed to air. And again, that's an example there of sodium reacting with water. Okay, finally, the third section is health. So contact with any chemicals or many chemicals can result in adverse health effects. It depends. The nature and magnitude, that means how big it is, of toxic effects will depend on many factors. That means it could be what is it made of, so the nature of the substance, route of exposure, so how you are exposed, magnitude of the dose, so how much you get, duration of exposure, that means how long, and individual susceptibility. So it varies from different individuals. So here are some examples of chemicals that may cause adverse health effects upon exposure. Irritants, it could be ammonia. Sensitizer could be formaldehyde. Target organ effects could be methanol. Toxic could be carbon monoxide. Reproductive effects maybe from chemo drugs, and carcinogens from benzene. So you might see this symbol. This is danger, chemical irritants, avoid contact with eyes and skin. Failure to obey this sign may result in serious injury. Okay, so basically be aware of the symbols or hazardous symbols to prevent harm. So here are your hazard symbols. So WHMIS applies to two major groups of hazards, physical and health. Each hazard group includes hazard classes that have specific hazardous properties. So physical hazardous groups, we talked about with some of these. It could be flammability, reactivity, or corrosivity to metals. And then the health hazard groups is based on the ability of the product to cause a health effect. So it could be an eye irritation, it could be respiratory sensitization, might cause allergy or asthma symptoms, or breathing difficulties if you inhale it, or carcinogenicity, that means it may cause cancer. So each category has its own hazard symbol, and it is important that the worker be able to recognize these. So here are some pictograms, means a picture. So the bold type is the name given to the pictogram, and then the words in the brackets describe the hazard. So the picture of the exploding bomb means is for explosion or reactivity hazards. The flame, we talked about that. That's for fire hazards. And then flame over circle is for oxidizing hazards. Gas cylinder for gases under pressure. Corrosion for corrosive damage to metals as well as skin and eyes. The skull and crossbones, that can cause death or toxicity with short exposure to small amounts. This one we looked at earlier, it's the health hazard, may cause or suspected of causing serious health effects. The exclamation mark means may cause less serious health effects or damage the ozone layer. This picture shows a tree, and fish and water is environment, may cause damage to aquatic environment. And finally, the last one is a biohazardous infectious materials for organisms or toxins that can cause diseases in people or animals. So the other one that I have, and I know that this has changed, so you might have had the older format. So this is what you might have for your WHMIS symbols. And this one says compressed gas, flammable and combustible, oxidizing material, toxic, immediate and severe, toxic, long-term, concealed, and biohazardous, infectious. Okay, that's from the previous or last year's material. There's also corrosive materials and dangerously reactive. So if you have this one, that's fine. Use the symbols there. If you have the newer format for this year, then use that one. So let's do the last of the key questions for lesson 3. So key question 59, it says circle the coefficients in this chemical equation and then circle the subscripts in this formula. Make sure that you go to your lesson book. So if you can't remember, go to lesson 3 chemistry, go to page 36. So this is page 36, and you will see the term coefficients, subscripts, and then it says the small letters following the chemical symbols. So coefficients, these are the large numbers in front of chemical formulas. So coefficients represent the number of molecules of the substance in the reaction. So an example of a formula that has a coefficient would be N2H3. So the coefficient would be the large number in front of the chemical formula. So number 2 is the large number. Okay, so that's the coefficient. Subscripts, the small numbers to the lower right of chemical symbols. These subscript numbers represent the number of atoms of each element in the molecule. So in this case, N2H3, the subscript is 3. Okay, that's the small number. And it's after the element H, which is hydrogen, so that means there's 3 parts hydrogen, okay, in that formula. So let's look at our key question here. Circle the coefficients in this chemical equation. Very straightforward. Look for the big numbers or large numbers. So you only have 2 and 3. So N2 plus 3H2 yields 2NH3. Those are your coefficients, 3 and 2. Make sure it's the large number. Circle the subscript in this formula. So you're looking for the small numbers to the lower right of the chemical symbols. This one says C12H22O11. So you circle 12, 22, and 11. Okay, those are the small numbers to the lower right of the chemical symbol. Key question 60, what does WHMIS stand for? So again, that's straightforward. You just have to write what does WHMIS stand for. It says what is the ultimate goal of WHMIS? That means what is it set out to do? So the ultimate goal is what? Okay, then the last 2 questions. Key question 62, why should you always follow instructions carefully when mixing chemicals? So I'm asking, why should you? You could say I should or you should. Okay, I should always follow. So why is that important? After talking about all the hazardous symbols, why is that important? And then the last key question says, a bottle containing a mysterious chemical was found in the science lab. The label for the mysterious bottle is shown below. What do these 3 hazard symbols mean? So there's 3 symbols that I need you to identify. So 1, 2, and 3. And that's it. That's it for PLAR, not PLAR, but lesson 3 chemistry. Okay, so we did key questions 59 to 63 just now. In your book, if you look at the different terms These are the terms that you can use to help you with key question 44. So if you haven't completed key question 44 yet, here's your chance to look at all the different terms that we came across on lesson 3. They are written out alphabetically, meaning beginning with A, alloy, atom, chemical change, chemical equation, right on down to the last term that we looked at, which is pure substances. So if you need help with key question 44, go to this page. Especially the different types of matter or classification of matter, heterogeneous mixture versus homogeneous mixture. There's also the word mixture, particles, pure substances, the word compound. Okay, they're all there. So if you haven't completed key question 44 yet, make sure that you take a look at this page. Okay, so here is lesson 4. Now your lesson 4 is physics. Each lesson will have the same information. So that's your cover page for lesson 4. It gives you the WASA studio number. It gives you the television for Bell Express View channel 972. So if you have that, you can check out our WASA classes. Now remember, this is audio. You won't see my desktop if you're listening to Bell Express View channel 972. It shows you my Zoom link, my meeting ID, passcode. If you need to get a hold of me in the office, or if you need to fax something, email, Facebook and YouTube, that's all there. Also the Google Classroom codes if you're using your NNEC Schools account. That means if you have your if you signed up for, or if you logged into your NNEC Schools account, or if you already have a personal Gmail account, that there is also the Google Classroom code if you want to use Google Classroom. So remember, if you do not have the 2023-2024 version, that's fine. I will accept the 2022-23. You don't have to start from the beginning. Let's say, for example, you completed as far as lesson 2 from a different version. That's fine. Get the newer version and start with lesson 3. So lesson 4 and key questions, you will start with key question 74 and end with key question 71. On page 3, you will see the learning goals. It says I can explain the laws of electrostatics, and then I can describe the similarities and differences between current and static electricity. So keep these in mind. This is what you will learn in this lesson. Electrostatics begin on page 3. Then we have types of charges on page 4, and law of electrostatics on page 5. And then we will look at charging by friction, the electrostatic series, conductors and insulators on page 7. So you can see it's not a very long lesson. There are only 8 key questions for lesson 4 and 9 key questions for lesson 9. And then we're done. Same thing. You will be required to complete the following key questions, like I said, beginning with key question 64 and then ending with key question 71. Once you finish all your key questions, then you will be eligible to write the PLAR Science culminating activity. The support questions, as always, are there for you for practice, and the answers are at the end of the lesson. That means you don't need to submit them for marking. Okay, physics. So physics is the study of the relationships of objects, forces, and energy. So physics explains gravity, meaning the way things move according to Newton's laws of motion. It also helps us understand behavior and movement of energy, such as heat, light, and electricity. So there are fields of study in physics. So under that, there's heat, forces in motion, light, waves, electricity and electromagnetism, electronics, and nuclear physics. There was a famous physicist, Albert Einstein, or famous scientists in history and physicists, Isaac Newton and Albert Einstein. You can check them out if you want. You do a Google search if you want to read more information about them. Continuing with page 3, the word electrostatics. If you want to use electrostatics, or if you are more familiar with static electricity, that's fine. This is the branch of physics, and what it deals with is the stationary electric charges. Okay, stationary means it's not moving. So electrostatics involves the buildup of charge on the surface of objects due to contact with other surfaces. So if you look at the pictures, you have the girl pulling her hat off her head, and the hair is attracted to the hat. Or if you have walked on the carpet floor and you get a shock when touching a doorknob or any other metal object, that's another example of static electricity. You might get clothes in the dryer and you notice that the clothes are stuck to one another. That's an example of static energy. When you have a plastic comb and you run it through dry hair, static energy is produced. So if you do this in a dark room, you will notice sparks. Same as when the comb is run through dry hair, the hair which is dry starts breaking and falling apart from each other, or it may be in strands and start moving apart. You could also see when you have a plastic comb is rubbed on a woolen cloth, a static electricity is generated. Because of this, the plastic comb can attract small pieces of paper. So all these pictures, these are all caused by static electricity. So what is it? Where we said it was an electric charge. It's not moving, so it's electrons at rest. Static means at rest, or it's at a point, and make sure that you highlight or underline it, means it's not moving. This is different from the other type of electricity where electrons are in motion through a conductor. So that's current electricity. So if you plug something in, that's current electricity. Electrostatics or static electricity is at rest. Make sure you make a note of that. It's static, it does not flow or move. So the buildup of electric charges has been known by people for over 2,000 years. The Greeks observed that a piece of amber rubbed with a piece of wool attracted small objects. So there's your amber. So electricity, and electron comes from the Greek term electron, which is spelled E-L-E-K-T-R-O-N, and it means amber. So static electricity is a form of energy that is made when electrons move. So what makes it move? Well, the electric charges of different particles in atoms is what makes it move. So there are three different types of charged objects. So we're going to look at each of them. This is on page 4. So the first one, we have a neutral object, which means that the number of protons equal the number of electrons. Okay, so let's just go back quickly to, let me just show you this in dual page. We talked about that what makes the electrons move. We said the electric charges of different particles in atoms. Well, an atom has, or the atom is composed of a nucleus which has inside it protons. Now the protons are positively charged particles. Okay, there's your proton. Or if you want to remember, P for plus, so the plus sign. And then neutrons. Now neutrons are neutral charged particles. Okay, it's neutral. It's neither negative or positive. Neutrons are neutral. So that one's easy to remember because it starts with NEU for neutrons and neutral, NEU. Around the nucleus there are electrons. So electrons, these are negative charged particles. This is the particle that orbits very fast. It is these electrons that are responsible for giving the articles the charge if they are rubbed or contacted or brought close to another charged item. Okay, so make sure that you look at what the atom is composed of. So it's made up of protons, which are positively charged particles, and neutrons, or neutrally charged particle, and then around it, around the nucleus, you have electrons. These are the negatively charged particles. So you can see that they're minus. If you can't remember all of these, or the different parts of an atom, think of it as pen, P-E-N. So P for protons, and protons are P for plus. E, electrons, and you can write minus, and then N for neutrons, and N is neutral. So there's, you can put O, zero charge, no charge. So when you spell pen, P-E-N, you get protons, electrons, and neutrons. Okay, let's now go back to the three different types of charged objects. So we have neutral, just take out dual page here. So neutral objects, you have the number of protons equal the number of electrons. That's why it's neutral. So if you have 8 pluses and if you have 8 minuses, it's the same. So there's no charge. It's neutral. It's neither positive nor negative. So if an object has an equal number of protons and electrons, the object is neutral. An object is positive if it has greater number of protons, positive, than electrons, which are negative. So if you count all the pluses in this object, you have 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 pluses or protons, and there are 5, 1, 2, 3, 4, should be one more, 5 electrons or minuses. So plus, minus. You do the math, which has more? So there's more pluses than minuses. That means that object is positive. Then finally we have a negative object. And you're right. That means that if you guessed right, if you have more minuses, in this case there are 12, and there are only 8 pluses or protons, then that object is negatively charged. Okay, that's fairly simple or straightforward. So what we're going to do here is we're going to look at our key question. Let me just bring that up. So beginning with key question 64. And you don't need to do a search, okay, on the internet, or you don't need to look it up. It's all in your book. You can put your hand on the answer or your finger on the answer. So key question 64, what did the ancient Greeks observe when amber, whoops, just get the pen here. It says when amber was rubbed with wool. So what did they notice? Okay, they noticed when amber was rubbed with wool. Tell me what they saw, okay, or what they noticed. Okay, we'll do key question 66 because we just looked at that, and this is where we'll end it. We will look at key question 65 in our next class. Just look at the type of charge these objects might have. So object A, I want you to count the protons, okay, and electrons for each object. So object A has 1, 2, 3 protons. So if I put protons, you have 3. And then electrons, 1, 2, 3, 4, 5. So electrons, you have 5. What is the charge for object A? So again, when you're looking at solving this, it's a math problem. Which has more, electrons or protons? Where electrons there are 5, protons there are 3. So the charge for object A is negative. Okay, it has more electrons than protons. And that's what you will have to do for the next two. Object B, count them. 1, 2, 3, 4, 5. So for protons you have 5. And then 1, 2, 3, 4, 5 for electrons. What do you notice here? It has the same number of electrons and protons. And what do we know about that? If you're not sure, go to your lesson book and read page 4. And finally, so this is the last one we'll do, object C, count the protons. 1, 2, 3, 4, 5. So protons you have 5. And then electrons, that's the minuses. So electrons, I only see 2. So which is more, protons or electrons? So whichever number is higher, that's what the charge of the object will be, whether it's positive or negative or neutral. Okay, so that's it. We will continue with this in our Wednesday's class. If you have any questions or problems, make sure that you contact me. Miigwech.